since we did not get all the way through these Chapter 18 Notes Part 1 yesterday, kind of had a lengthy lab and story time, kind of messed us up, then we need to finish that now. So let's do a quick review. So here we go. Quick review. First of all, let's recall these symbols over here. A regular old P is your population proportion. A P hat is your sample proportion. Okay? And where would you expect all of those samples to be centered? At the same as the population. So the mean of all of the P hats that's your symbol for that, mu of P hats. And then you also have a standard deviation of P hats. That's how varied all of your samples will be. Okay, now taking a look over here, of course, we remember from yesterday that the standard deviation of P hats has a formula that we used. Here is the work that we did. And remember yesterday that I also asked you to now start writing your answers in this format here. So let's go ahead and do this problem here, number 2. I kind of would like to see if you could do it on your own. So let's let you read that problem and get started trying to do that. Okay, so do that now. We're on, it's number 2.
What page?
23.
23, geez, almost right. There we go. Yes, sir.
Well, you can start with what the sample size is. See, do you see these things that are over here on the left? That's a clue. Figure out what all those things are for this problem. Okay? The mean of the P hats is going to be the same as the whole. So they're saying, the engineers don't know this, but in fact, there are 3% defective of all of the switches that they're talking about.
In the upper problem, where'd that 0.4 come from in the standard deviation equation?
This 0.4 is the opposite of the 0.6.
Oh, okay, thanks.
All right, so then remember that your standard deviation is your P hat, or I'm sorry, your Z-score is your P hat minus the P over the standard deviation of P hats. Okay, did anybody double check me on that standard deviation? I can't remember if that's actually what it was. Did anybody?
Oh, that, yeah, we did square root it. Yeah, square root.
Did you square root it?
Yeah.
Oh, really? Okay.
Square root of 0.03 times 0.96.
All right, you're right. Hey guys, listen up. You're right. I miscalculated that. So there, it's 0.00985 was your standard deviation. So there's what you came up with. Okay, so check that there. All right, and then let's not forget that I want you to finish this thing out by saying the probability. You don't have to write this paragraph. The probability of getting a P hat that is more than 0.05 is 2.12%. Okay? Yes?
How do you want us to round on finding your standard deviation? I want something like that.
So I do not know. I think on standard deviation I usually go to 3 decimal places because I don't like to round very much in the middle of a problem. I'll round at the end to 2 decimal places, but I don't like to round in the middle of it. But I'm going to tell you also that if your numbers are a little bit different, like you did 0.0098 because the 5 was actually a 4, then, and you get a little bit different number, then that's fine.
Okay.
It's not going to be, that's why the work is important. And on AP, that's what they'll look at. Okay, yes ma'am?
Okay, so why do you always draw random p hats like in the middle of the thing? What is that?
So these P hats represent somebody's sample that they took and the value that their P hat was.
Oh, and
So,
that's the P hat.
so they're all going to be in here. So these are random P hats because they are people's samples that they got.
Okay.
All right, let's go ahead and move on, guys. Let's talk about yesterday in this class. I did not have us do the problems in the homework, so we're going to do that real quick. So if you would skip over to page 27. So this first set of homework that we were supposed to do last night is the proportion problems. So, but then shortly, here after I finish going over this with you, then we're going to talk about the mean, and so you'll ultimately be doing them all, okay? So here we go. Let's take a look at this. First, what I want you to do is read problem number 1 and 2 and see if they are a mean or a proportion problem. So I'm on page 27. Problem number 1 says the scores of the individual students for the ACT have a mean of 18.6 and a standard deviation of 6. All right, so then they want to know, would a sample have a mean of 19.2 or higher? So do you think that's a mean problem or a proportion problem? That is a mean problem. So then we would not do the work for that yet. Okay? So let's take a look at problem number 2. Problem number 2 says, census data for a certain county shows that 19% of adult residences are Hispanic. So the whole county, 19% of those adults are Hispanic. So that means in order to have a representative sample of Hispanics on a jury, what proportion of Hispanics would I want on the jury? Also somewhere close to 19%, especially if I had a Hispanic defendant. All right. So there's what's happening. They took a sample of 72 people, and of those 72 people, only 9 of them were Hispanic. And so they think, whoa, that might be really low. And so this method that you have to pull jurors might not be giving us a representative sample of Hispanics. And that's a concern. If you were on a law team, big law firms have their own statisticians, and that's the kind of thing that they would figure out, okay? All right. So what is the probability of getting no more than 9 Hispanics out of that sample of 72? And then does that call into question? So go ahead and skip over to page 29. So then on page, I think it's 28. So then on page, is it 29?
No, it's 29.
Oh, okay, it's 29. Oh, yeah, I know why. Okay, so then this is on page 29. So these are, I put a mean on it and a proportion. They may not be in order. So do be aware that when you do these problems that, that's why this is blank. Okay, so it did happen that problem number 1 was a mean problem, and we're not going to do that problem yet because we've just studied proportion problems. Okay, problem number 2 is our proportion problem, and that's what we just studied. All right, so let's go through and start giving us some information for this problem number 2. First of all, we know that the P is the proportion of the jury that is Hispanic. All right? And it should mirror the same value that's in the county. So if it mirrors the same value that's in the county, what should P be? 19%. Very good. All right. So now let's go down here. Can you tell me, again, what does this mu of P hats mean?
It equals mean.
It's the mean of
The sessions.
all the P hats. So if you took a whole bunch of samples, they should be centered around the true proportion, which is 19%. Okay? Now, tell me, this standard deviation of p-hats tells me how varied can those samples be? And so that's a formula. Square root of p times 1 minus p over n. So let's fill in our numbers. Square root of p is 0.19. So the flip side to that is 0.81. And our sample sizes, what were our sample sizes on this problem?
72.
Good. They were taking samples of size 72. All right, so when I get that right there, 0.0462. Okay. And so then, what is a p-hat standing for in this problem? Yeah, your sample proportion of the jury that is Hispanic. And let's talk about what number we got in our sample. If you go look at the wording of this problem, it says, what sample did they get?
9.
Good. They got 9 out of 72, which is 0.125. Okay, so are you following most of that so far? That is all facts plus some formulas that we learned. All right, so this problem is basically saying this. A p-hat is a sample of 72 and the proportion that are Hispanic. So you could take lots of different samples, and these are different sample proportions. But most of the time, the proportion of the jury that is Hispanic should be how much? 0.19. But guess what? We got a p-hat down here. We got a p-hat right here at 0.125. And if it says, what's the probability that we have no more than that, which way do we shade? Then we will shade to the left. And so let's z-score that and then norm CDF. Okay? So it's not x minus the mean over standard deviation anymore. What is it? Good. P-hat minus the p over your standard deviation of p-hats. And so in this case, that's my 0.125 minus the 0.19 over that standard deviation that we got up above, 0.0462. And that is negative 1.406. Okay? So, hey, even before we do anything else, that sample is 1.4 standard deviations below the mean. What do you have to say about that 1.4 standard deviations below the mean?
It's not that bad.
That's not that bad. It is not an outlier. They got a different result than me because of
Standard deviation.
Variation.
Sampling variation.
sampling variability.
Get out of my house.
You got a different sample from me, sample results than me because of sampling variability. So listen up. This sample could have happened just because of sampling variability. It is not an unusually low number. So let's go ahead and get our area. So to get our area, we're going to norm CDF from negative 99 up to this negative 1.406, and that is somewhere around 7.99%. And so we're going to then give our answer. The probability that I get a p-hat that is less than negative 1 point, actually it could be equal to, but in this, when we do normal models, we kind of don't quabble about this little equal to. It's so slight of an amount, is 7.99%, okay? And then I want you to go ahead and save this answer. We're going to end up having a discussion about those in context. What's the ramification of those and such. Let's save those ones for later. So that last thing on the answer, go ahead and save those for later on this whole entire assignment. Yes, ma'am.
Where you put negative 1.406, could we put 0.125?
Oh, hold on. I made a mistake. And we get a stamp right here for pointing that out to me because this is wrong. Because negative 1.406 is a z-score, not a p-hat. What's the value of the p-hat? 0.125. That's what's supposed to go there. Okay, because the p-hat was 0.12. Okay. All right. So then in summary, what you were supposed to do was look at these 8 problems on pages 27 and 28. 5 of them are proportion problems and 3 of them are mean problems. Okay, so I'm going to give you a little bit of time to maybe do another proportion problem. Find the next one that's a proportion problem and let me have you do that before I start talking to you about the mean problems today. All right, so go for that.